Okay, they're asking us to, using the graph, write a limit expression that has a result of -3. The graph doesn't really ever get to -3, but it does approach -3, but just from one side, which is why I picked this problem. I want you to be able to remember that you have to specify that the graph is approaching -3. I'm sorry, the limit is approaching -3 specifically from the right side. So the way we put all this together, we definitely want a limit in there. We definitely want to say x is approaching 3. That's the x coordinate we're getting close to. But we're doing it specifically from the right side, so we need a plus superscript. And then, of course, don't forget to specify that we are, in fact, talking about the function f of x. The limit as x approaches infinity of the function. And we kind of have to take the leap of faith here. I guess I could have worded this a little better. We do sort of have to take the leap of faith that this graph isn't going to pull any surprises, and after this, cuts off, starts doing fun things. We're just going to assume that we keep pretty close to whatever height that is, and that happens to be a height of 4. And then finally, list all the c values for which the limit as x approaches c would not exist. Just from -2 to 22. The only place the limit doesn't exist would be when x is approaching 3. The limit does exist when x is approaching 5 because the one-sided limit's the same on both sides. Now the function doesn't exist. There's a hole in the graph, but the limit does because the limit only really cares about what's happening as you get close to the point.